Okay. Excuse me. I didn't put that where I can click it. Okay, so we talked about independent dependent events and the basic counting principle. So I can just multiply ways to go about doing that. And sometimes that's the easiest way to do a problem. Other times we have to talk about how do we do it if we're doing bigger groupings. We have larger amounts of items. Surely there's a way to do it. And that's what this part of the video is about. Ooh, change of color, I like that. Okay, so what we're going to talk about today is permutations and combinations. I should say in this lesson. What are permutations and combinations? Well, a permutation is when a group of objects or peoples are arranged in a certain order. The arrangement is called a permutation. So if I take a group of things and in that group I put them in an order, such as what if we wanted to line up everybody in the room going out the door? That's an order, because once you're in line at the beginning, you can't be in line again later on. And it matters on how we go out the door. Okay? The other one's called a combination. Now, a combination is an arrangement, or again, a selection of objects or people in which the order is not important. That's called a combination. So, let's take it this way. Let's say you have your class and you're going to elect officers. Is that a permutation or a combination? Well, if you're going to select officers, that means a certain person is going to be president and another person is going to be vice president. So that is a permutation. But let's say we took your class and you're just going to form a prom committee or a float committee. Well, it just doesn't matter who's on that committee or what order they get on the committees that they're on it. That's a combination. The order didn't matter. So let's start and see if we can figure out how this works. Okay, so determine whether each situation involves a permutation or a combination. So we're going to seat 8 students in 8 seats in the front row of the school auditorium. Permutation or combination? Answer is permutation. Because it matters. Because once we get them in those order, they're all there. Okay? Let's say I want to choose 2 movies to rent from 5 different movies. I got 5 movies there. I got to get 2 movies. It doesn't matter if I pick movie A first or movie A second, if it's one of the 2. So that's a combination. Okay? What if I want to arrange the letters in the word rhombus? Okay, in this case, my objects are these letters. If I think about a combination and the order doesn't matter, well, that's not going to work in this, because every arrangement that I come up with is going to use the exact same letters. It's going to say it's the same combinations. Now, let's say I was taking that out of the whole group of, that'd be a different story. So this one is a permutation because we have a word there, and we have to use all those letters. Okay, so let's say we're trying to find the first, second, third place finishes in a race with 10 contestants. Okay, first, second, third. Those are identified order items. So that's a permutation. Say we want to elect 4 candidates to the municipal planning committee out of a group of 7. Okay, that's a combination. Okay, 4 candidates. We don't care who they are. Okay, say I want to check out 3 library books from a list of 8 books from a research paper. Okay, 3 out of 8. Again, it doesn't matter the order I get them. That's a combination. Okay, introducing the 5 starting players of the Woodsville High School basketball team. Okay, here, we got the 5 starters. We have all 5 of them. We have to announce all 5 of them. So combination doesn't make sense there, because let's say you only got 1 combination. You only got the 5 starters. Okay, so that's definitely a permutation. Okay, let's say I want to have a committees. So we got from a group of 10 men and 12 women, how many committees of 5 men and 6 women can be formed? Okay, now here, this is a combination of combinations. Because I got to look at it as, okay, I got to get 5 guys out of the group of 10. That's a combination. I got to get 6 women out of the group of 12. That's a combination. Now from that, since I've got 2 groups, male and female, I combine this with the fundamental counting principle. So I'm going to take those two combinations and multiply them together. So that's the way that works. Okay, so now we figured out whether or not they're a permutation or a combination. The next thing to figure out is how do I calculate these permutations or combinations? Well, if it's a permutation, the number of permutations of n distinct objects taken r at a time. So if I had 12 items taken 5 at a time, then it's written as p of n comma r is equal to n exclamation point over r n minus r exclamation point. That exclamation point is referred to as factorial notation. It is a factorial. Anything with an exclamation point behind it, that's a factorial. So what does that mean? N factorial means I've got n times n minus 1 times n minus 2 all the way down the line until I get to 1. So an example of that is if I had, say, 5 factorial, that would mean I got 5 times 4 times 3 times 2 times 1. So all I do is I take the number of outcomes and I multiply down. Now, depending on the number of items you have for permutations, it's the basic counting principle of dependent events. That's really what it is. It is a dependent event, and you're going to use the basic counting principle, and you're just going to count down. What happens is when we do this n minus r stuff here at the bottom, I need to get the magic pen out here real quick. There we go. So when I do this thing down here at the bottom, it's n minus r, what that does is it eliminates all the extra values that I don't have. So when I talked about doing, what was it, 10 and 5, so the p of n, 10 and 5, I would take 10 factorial and divide that by 10 minus 5 factorial and get to my answer. That's the way we would work through that problem. Okay, so now a combination. I don't think I have, oh, I do have something else there. N, oh, that's by factorial notation. Got to make sure I bring this in. By definition, 0 factorial is 1. So just know that. If I have a 0 with an exclamation point, that's a 1 there. That comes into play. Now, as far as calculating a combination, I do it like this. So I have the number of permutations of n objects, of which are p alike and q are alike. I got that in the wrong spot. Number of combination of n distinct objects taken r at a time is given by c, parenthesis n minus r equals n factorial over n minus r factorial. So notice the difference here is this little guy right here. I lost my pen. This little guy right there. That extra r factorial on the bottom. Because that means I have that many groups to go in there, and I got to take those out. Okay, so formula for those two things are pretty much the same. Let me get this one out of here for just a minute. Okay, so notice the formulas are about the same. The only thing different is the combination has that extra r factorial in the bottom. Now, we might see this written in several different ways. We might see something like c of 10 comma 5 or p of n comma 5. We also might see it like this. That still says 10 objects written, or 10 objects permutation, 10 objects taken 5 at a time. If you're going to use your graphing calculator or your calculator to help you calculate it, you're probably going to look for something that looks like this or this, NCR and PR, and they stand for permutation and combination. And all it does is it just takes these two numbers and sticks it into this formula. They're just quick buttons that do that for you, but you have to be able to put them in there. So you have to understand what that notation looks like. So those are the two things there. Okay, so now this other item here says, okay, what if I have permutations of n objects of which p are alike and q are alike? Okay, so if I've got to use everything in the group, and such as the word rhombus. Okay, so I have rhombus, and I want to find out how many different ways I can rearrange the letters in the word rhombus. I'm going to use that formula. So on the top is how many letters are in the word rhombus. On the bottom is how many numbers, how many things repeated. And when I talk about how many things repeated, it's how many times did they repeat. So if I think, say like Mississippi, M-I-S-S-I, S-S-I, B-P-I. Okay, how many S's are there? There's 4 S's. So that would be like the P would be a 4. And there's 2 two P's. Mississippi, yeah. And that would be a 2. So then I'd have a 4 and a 2 on the bottom with the factorials. But then I also have the I's, so I'd have to have that in the bottom as well. So anytime something repeats, the number that goes in there for P or Q is how many there are alike. How many of them are the same letters? So that's what that comes in. Okay, so those are all those items. So what do we do down here then? Well, there's another set of directions to this. It says determine whether the situation involves a permutation or a combination, and then find the number of possibilities. Okay, so we said this was a permutation of 8 items taking 8 at a time. So that means, I'm going to switch this back to a different color. There we go. Okay, I don't know why I was going to do that. Okay, so I want a permutation of 8 things taken 8 at a time. So if I was using the formula, that'd be 8 factorial over 8 minus 8 factorial, which would be 8 factorial over 0 factorial. And this is where that definition is very important, because 0 factorial is 1. So that's 8 factorial over 1, or just 8 factorial, which means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And now if I go to my calculator, I can run that through, or I can multiply it out by head. So I can take 8 times 4, 7 times 6 times 4, 5 times 4 times 2 times 6 times 1, and I get 40,320 ways to line those 8 people up from that front row. Okay, choosing 2 movies from a group of 5 movies. So that's a combination, so C, 5, 2, which means I got 5 factorial over 5 minus 2 factorial times 2 factorial. So whatever that second number is goes into the bottom twice. So that means I got 5 factorial over 3 factorial times 2 factorial. Now notice the 2 numbers on the bottom add up to be the number on the top. That's important. That's the way to remember how to do the combinations. And now we could just run it out. So I got 5 times 4 times 3 times 2 times 1 on the top, divided by 3 times 2 times 1. I should write that out, huh? Not 5. 3 times 2 times 1 times 2 times 1. Well, 3 times 2 times 1 is listed on there twice. So why put them down? Okay, and then 2 goes into 4 2 times. So I actually have 30 different ways to do that. Now, I can show you how to do this on the calculator if you want to know. And I'm going to start doing that for my own calculational purposes here. Okay, an arrangement of letters in the word rhombus. Okay, so the first thing, we said it was a permutation. But we got to realize it's not a permutation like the rest. It's a permutation with a possibility of repeats. So we're going to use all the letters. So I got 1, 2, 3, 4, 5, 6, 7 letters. I got all 7 letters. Now, are there any repeats? I got an R, an H, an O, an M, a B, a U, an S. No repeats. So over 0 factorial. So 7 factorial is my answer. And that's going to be a little less than what the 40,000 was. So it's 5,040 ways. What if that was a different word? What if instead of rhombus, it was parallel? Okay? So if it was parallel, it would still be the same kind of thing. It would still be in a permutation. And if I look at it this way, I've got 1, 2, I spelled parallel wrong. R-A-L-E-P-A-R-R-P-A-R-L-L-E-L. There we go, parallel. So, don't know what was going on there. I got 2, 4, 6, 8 letters, 8 factorial. Well, how many of them repeat? I've got A's are in there twice, L's are in there 3 times. So I would have 8 factorial over 2 factorial times 3 factorial. So 8 factorial divided by 2 factorial times 3 factorial. And I would get 3360. So when we have multiple letters, now we got to see how many things are repeating in it. So I had 2 8s. So it wouldn't matter which way I put the 8s. That's why I got to divide that out. Okay, so now here we have a permutation of 10 items taken first, second, third places, 3 at a time. I just want to know those 3 spots. Now I could use the calculator, and I could run that thing through the system, and I would put it in as a permutation of 10 items taken 3 at a time. And that tells me I've got 720 ways to do that. The other way is, in this case, since it's only 10, and only 3 places, we can do it pretty easy, saying, well, there's 10 first places, 9 second places, 8 third places. So I still get 720. Okay. So now the next one, it would just be a combination of 7, 4, and we can do that pretty simply as well. Run it through the system, and there's 35 planning committees that can be made. Combination of 8 things, taking 3 at a time. There's 56 of those. And let's see, 5 starting players, permutation of 5 things, taking 5 at a time. So here you really could just, say, oh, hey, I could just list all of them all the way down the line. 5 times 4 times 3. Or we can run through the system. Or we can say, hey, this is just 5 factorial, which is, I drew a blank for a second, sorry, 120. Okay, so now let's talk about this last one. I got a committee. So I talked about this before, and what I got to do in this case here is I got to find how many ways can I get the guys, how many ways can I get the women, and I got to multiply those. And that's the way I can find out how many, because I got, the first way is how many ways can I get all 5 of those guys. And there's 252 ways from that group that I could get those guys. Well, now I also have to do the women. How many ways can I get all of those women? Well, there's 924 ways to get the 12 women from that group of, the 6 women from that group of 12. Now, if I multiply those 2 values, I get 232,848 committees can be formed from these 12 people. Now, that's different than saying, well, how many 11 people groups can I get from these 22 people? See, that would be a different number. So, watch for those. Okay, the assignment. I got a worksheet for you. Work through the worksheet, and I think you're ready to go.